Algebra 2, 5.1, Properties of Exponents. So we're going to start with just a basic review of properties that you would have learned in Algebra 1. So first of all is if I have two bases that are the same, like in this case a squared and a cubed, and I am multiplying those, I need to add my exponents. And so the reason this works, if I think about a squared, I have two factors of a. If I have a cubed, I have three more factors of a. So altogether there's 5 of them. And 2 plus 3 would be 5. So it's a to the 5th power. Next is power of a power property. So this is when I've got parentheses and my power is raised to another power. In that case, I am going to multiply the exponents. And again, the way this works is if I have a squared and then it's cubed, that means I have a squared times a squared times a squared. And we've already shown that this we could get by adding 2 plus 2 plus 2. And so I get a to the 6th power. So for the next one, it says to find a power of a product. Find the power of, and in this case, I have both a and b in my parentheses, so both a and b. So basically, I am distributing here. I can distribute exponents over multiplication and division. So my answer would be a cubed, b cubed. To divide powers with the same base, so this is quotient of powers now, I can subtract the exponents. So if I'm multiplying, I add. If I'm dividing, I subtract. So 7 minus 3 would be x to the 4th power. And the way I get this is I have 7 x's in my numerator. 1, 2, 3, 4, 5, 6, 7. And I have 3 in the denominator. When I cancel out common factors, I would be left with 4 factors of x in the numerator, which is x to the 4th power. So let's also think about how if I had the x to the 7th in the denominator, then my x's would be left in the denominator. That would be 1 over x to the 4th. So if I'm going to start subtracting with my 7, then I have to leave where I have more factors. So it's going to be x to the 4th. It would be in my denominator in that case. There are lots of different ways to work out problems that have exponents. So generally speaking, in a problem like A, I like to simplify my numerator first and then worry about the denominator. So in my numerator, if I have 5 to the 4th and 5 to the 8th, I can go ahead and add those powers. Remember, I'm multiplying my powers of the same base. And so 4 plus 8 would be 12. So I have 5 to the 12th power. So notice I'm only adding the 4 and the 8. I'm not changing the 5 at all. And then it's being divided by 5 to the 7th. So now I'm dividing. I can use that property where I subtract my exponents. And 12 minus 7 would be 5, so I have 5 to the 5th power. And for something like this, I don't need to actually go through and work out and find out what the answer is. For B, I have 1 over x to the 4th times x to the 6th, so I'm going to put this over 1. So I can just kind of see how I'm multiplying. When I multiply fractions, I multiply straight across, so I'll have x to the 6th divided by x to the 4th. And now I have, just like in the last one where I've got a quotient, I'm dividing, so I can subtract my exponents again. 6 minus 4 would be 2, so I have x squared. And the next one, I have a couple different properties working together. First, I need to distribute that cube, and I'm distributing over multiplication. So I'd have 3 to the 3rd, and I would have d to the 5th raised to the 3rd power times one more factor of d. So 3 to the 3rd would be 27. I wouldn't do 5 to the 5th. I know that's going to be a big number, but 3 to the 3rd is pretty manageable. Here I have power to a power with d, so I'm going to multiply my exponents. So remember d to the 5th, and then I have like 3 groups of d to the 5th. So that means d to the 15th times one more factor of d. So now I would want to think about adding those exponents. 15 plus 1 would be 16. So I have 27d to the 16th. So the next two properties are just talking about 0 and negative exponents. So anything to the 0 power is 1. So here we have a to the 0 power equals 1, but a itself, of course, can't be 0. Our example is 5 to the 0 power is 1. A to the negative n power and a to the n power are reciprocals. So if I have a negative exponent, I put it in the denominator, and now it's positive. So those are reciprocals. So as an example, 2 to the negative first is 1 divided by 2. So it's 1/2 instead. So for example 3, we're going to look at these negative and 0 exponents. So 5 to the negative third power means 1 divided by 5 to the third. So I've taken a reciprocal. And then 5 to the third would be 125. In the next one, I have something to the 0 power. And notice how there's parentheses around the negative 3. So that's going to equal 1. If I add negative 3 to the 0 power like this, I would have to do 3 to the 0 power first and then make it negative. For order of operations, that exponent would come before the multiplication, and so that would be a negative 1. On the next one, I have negative 4 to the negative 2 power, or sorry, 1/4 to the negative 2 power. So I need to do the reciprocal. So reciprocal of 1/4 is 4. And when I take the reciprocal, now my exponent is positive. And 4 squared would give me 16. Last one, 0 to the negative 5th power means 1 divided by 0 to the 5th. But when I have 0 in my denominator, it is undefined. On the next page, we're looking at continuing to simplify, but now we have more complicated expressions. We have negative exponents as well. So on A, I would get rid of the parentheses first. And I might even move my y first. That would be another option, like get rid of that negative exponent. But either way, you'll get the same answer. So I'm going to go ahead and distribute. So 3 squared. All right, come on, color. So 3 squared. Sorry, technical difficulty. 3 squared. Why are you not writing? 3 squared. And then I have x squared. And then I have y to the, y is power to a power. Negative 4 times 2 is negative 8. And then I would actually evaluate the 3 squared as a 9x squared. And because my y is to a negative exponent, I would take the reciprocal. So that would move the y part to the denominator, and now it's a positive 8 exponent. For b, I have this whole chunk of stuff, 5x, that's being raised to a negative power, so I'm going to move that down to my denominator. And I can see I only have y in one place, or I only have y in the numerator and denominator. It's not anywhere else, so I'm going to go ahead and simplify that right away as well. So when I simplify my y's, I have 4th power, 1st power. So if I crossed out one factor of y, I'd have 3 left over in my numerator. So I'm going to write down y to the 3rd. And in my denominator, now I have that 5x that's being squared times a negative 2x cubed. Remember that y has been canceled out. So now I'm going to go ahead and square the 5x. Again, there's a lot of different ways to go through and show the work steps in these. As long as you are not doing too many steps at a time so someone can follow your work. So when I square the 5x, I need to make sure to square both the 5 part and the x, so I get 25x squared. I think I can continue this with just one more line. So my y cubed is alone in the numerator, and now in my denominator I have x in more than one spot. I can put those together. So negative 2 times 25 would be a negative 50, and x squared times another x squared would be x to the 4th power. So we are adding these exponents because they're next to each other, so we get x to the 4th. But we're multiplying the coefficients. So for example 5, I have 4.5 times 10 squared times 2.3 times 10 to the 5th. So we're looking at numbers that are in scientific notation, and we're just going to look at some shortcuts to maybe go ahead and multiply these out using properties of exponents. So what I normally like to do is I like to really just break this up and write it differently so it doesn't look like scientific notation. And I would write this as 4.5 times 10 squared times 2.3 and then times 10 to the 5th. And this is not at all a necessary step, but I just find that it really helps students understand what I'm doing on this. So now that I've written it like this, most people agree we can multiply in whatever order we want. So I'm going to choose to multiply the 4.5 and the 2.3 first. And then I have this 10 squared times 10 to the 5th that I'm going to do. So the 10s, if I have 2nd power and 5th power, I know I have 2 factors and then 5 more factors. I'm going to have 10 to the 7th power. And then the 4.5 times 2.3, I'm just going to do on a calculator. And I get 10.35. So now my last problem is that when I have scientific notation, I only want one digit before the decimal. So I need to move my decimal one place this way because my number was too big. And since my number was too big, I'm going to have to add a factor of 10 over here when I move that decimal. So now I'll have 1.035. I want to use the x to show its scientific notation, times 10 to the 8th. So instead of figuring out 4.5 times 10 squared, instead of coming up with that long number and the 2.3 times 10 to the 5th, instead of both of those being these great big long numbers that I have to multiply them and then change it back, I can actually use some tricks and multiply them while they're in scientific notation. So on the next one, I can break it up similarly. I am cubing 3.7 times 10 to the negative third. So I'm going to take the 3.7 and I'm going to cube that part. And then I'm going to take the 10 to the negative third part and I'm going to cube that as well. And I'm not going to do any reciprocals for negative exponents here because when we work with scientific notation, we don't want reciprocals. We actually want negative exponents. So 3.7 to the third power goes on the calculator, and I get 50.653. And I have times 10 to the power. To a power means multiply. I have three groups of 10 to the negative third, so I would multiply those. And then again, my number is too big, so I need to move my decimal. And because it was too big, I will have to add one. And so my new answer is 5.0653 times 10 to the negative 8. And again, I'm switching back to x's for my final answer because scientific notation is written that way. It's just expressed that way. All right, so on this last one, we're going to do something similar again. Will be just like if I had an x and a y in my numerator and an x and a y in the denominator. X's can be simplified with x's, y's with y's. So I'm going to look at dividing the 1.2 times the 1.5, or sorry, 1.2 by the 1.5. 1 and 2 tenths divided by 1 and 5 tenths, so 0.8 times. And then here I would want to subtract my exponents. So 10 to the 5th minus negative 4. So 5 minus negative 4 would be 5 plus 4. So 0.8 times 10 to the 9th. And then because my number is too small, I want to move the decimal one place to the right. Since it was too small and I have to increase that number, I'm going to subtract 1 from here. So now I have 8 times 10 to the 8th. That is it for our 5-1 notes. Please ask questions in class.